Welcome back. Well, I thought I'd have a go at doing this gimbal system, this self-balancing robot, or if you want to call it a Kalman filter stabilised platform perhaps. And I thought I'd do it differently. I thought I'd use this servo, which is the AR3606HB, and what's different about that is that it's not a position servo. It's been doctored so that when you put PWM into it, the speed changes rather than the position. And I believe you can do this to any servo, but I got these ready-made, and I think they're supposed to be quite good. The logic behind this is that I don't actually need position servos when you're making a stabilized platform. A stabilized platform only needs the ordinary motors driven by say H-bridges. This doesn't require an H-bridge, so I'm sort of doing it without an H-bridge. Otherwise I could use ordinary motors, but again I've got to do a mechanical construction really to put together, and this is my gimbaled construction, which is 3 degrees of freedom that way, which I'm not using, the yaw, that way, which is roll, and pitch, which is in this direction. And it took rather a long time to get the control system for this. It was much harder than the other one because it kind of runs away and hammered back and forward like a typical servo. You can sort of jumps off the table, so you've got to be careful that you don't actually damage things or other people's property around it. But eventually it does work, and it does seem to be faster than the previous one, and it certainly feels like it. You've got to watch you don't put it into gimbal lock where it's all screwed up and both are at 90 degrees. Oh, there you can see it correcting itself up. It's a bit of a strange animal. There's a 3D model in the background. So the control system's much the same as before. It's PI plus a phase advance in both degrees of freedom for the roll and for the pitch. I've got first cutoff of 20 Hz and what looks like, because I've sort of tuned it in, about a kilohertz bandwidth. That seems a little bit on the high side, but that's what the readings are saying, which is quite massive. I don't think the motors are responding like they were 1 kilohertz bandwidth, maybe because of the gearbox is slowing them down. So maybe the next stage should be not to have gears and just have direct drive, do it that way, and that might be possible as well. 2 Kalman filters. You could have one big one, but they're decoupled, so it doesn't matter. So 2 Kalman filters, each measuring the position and the velocity of the individual pitch or roll. So as I move this, it corrects itself because it's in a closed loop system. That wasn't very good, was it? That's the, you see the 3D model moving. So that's about it really. Classical control meets with so-called modern control. It's not really modern anymore, the Kalman filter, and you combine the two and to do something like this. Thanks very much, bye bye. Now let's move it around a bit. Is it moving back up vertically again? That's a roll. I've got to be careful I don't get gimbal lock, as it's known in the Apollo mission. Look at it. Interesting. Sort of folds itself. Oops, a couple of screws come out. The 3D model over there. Okay, I'm going to try and start it up from this strange position. That's gimbal lock. Start it up from here. Oh, started on its own that time quite easily. And there it is balancing itself. As I move it around. It really feels, it feels alive actually. It's got a lot of gain in there. It's by no means the best mechanical design, but certainly very interesting to have a look at and have a play with, really. Having taken a whole day to get this far, the controller is quite difficult and much more difficult than using ordinary position servos. This is of course using velocity servos, really motors with feedback around them. I'm going to try and start it up from this strange position. That's gimbal lock. Okay, so I fixed the camera at the top, the little FPV camera, and I've got the image on the screen. I'm just going to yaw this round so it's pointing at me, and you've got a reference there. As I move this contraption, hopefully it should stay looking at me at all times. Even as I tip it over there at that angle, it's still vertical. Likewise the other direction. Go that way. All directions. It's still pointing in my direction. We have it. Yaw it round there. So that's a little demo. So that's the system working off lag lead controllers, or PI lead type controllers. I can explain them at another time. With two Kalman filters, just measuring the pitch and the roll angles. Although I am measuring the velocities, I'm not using those measurements at the moment. Thank you.